Hi, today we're going to work on rational exponents and their radicals. And this was not on our intro day to exponents, but it follows in line very nicely. And I think you'll find that this is really pretty easy. The big summary is, did you put it where it goes? That's pretty much it, in a nutshell. Simplify maybe if possible. That's it. Okay, so let's get your name on here. That way your papers never get mistaken for somebody else's. All right, so the rules that you have not seen before are stated as such. If you have an exponent that is a fraction, whatever the denominator is of the fraction, the denominator, that is the root of a radical. So that is the number of times that I needed to make something tear apart into its prime components. If you have a fraction as your exponent, whatever the numerator is, that is how many times the base is going to happen. Still, even if you tear down your base using a radical. So the big summary, fraction for an exponent, the numerator is still making things grow. It is still the numerator. The denominator is in the root of the radical. All right, let's see how this works. Putting things where they go. So we are asked, what is 8 to the 3/2 in radical form? We are also asked to simplify it if possible. Okay. Well, isn't that interesting? They changed the problem. They have a typo. This is supposed to be 2/3 according to this problem and the rest of the problem. All right. So what is 8 to the 2/3? Nice job, worksheet. Anyways, so my numerator of 2 goes there. That says 8 will be squared. And I am looking for the cube root. So there it is. So let's go see, can we simplify this? What is 8 squared? 64. And then we're going to factor out 64 to see where it came from, to see if we can make any bundles. So this is a review from 7th grade, 8th grade, I don't know, it's been a little while, of factor trees. Usually we're going to divide by the smallest thing possible. 2. 64 divided by 2, 32. All right, is 2 prime? Yes. Leave it alone. Is 32 prime? Not even close. What is the smallest thing that will divide into 32? 2. So 32 divided by 2 is 16. Yep. So 2 is still prime. Is 16 prime? No, it's a composite. 16 comes from 2 divided by 8. 8 is not prime. 8 comes from 2 and 4. And 4 comes from 2 and 2. So what we see with a cube root is I am looking for bundles of 3 of the same thing. I am not looking at any of the composites. I am looking strictly at the prime numbers. I have 3 2s right here. Let's circle them up. And I have another 3 2's right here. Let's circle them up. So now that I have bundles, I take a representative of each of my bundles. I have a bundle of 2's. I have another bundle of 2's. And a representative, well, multiple representatives, we just multiply them together. It was all multiplying here. It was all multiplying here. And we get 4. The same as that 4. So you've just seen there's a couple of different ways to walk through this. It's not too bad. There's a quick thing that we need to discuss, and that is x to the 1/2 power. But this will come to get better and better, and it just takes practice. But you've been finding your least common multiples, your greatest common factors, your primes from your composites for a long time. So the rule of thumb, what's the smallest thing that can divide into that? There you go. All right, let's make a note up here on your paper real quick. X to the 1/2. That is the same thing. Let's rearrange as this root with a 2 here in the radical and a 1 right there. What kind of root is this? It's a square root. Square roots, we don't usually have a number there. They're just written like that. So a lot of times we have ones that are assumed. They are understood. Here we have a slight shift where we have a 2 that is understood. It is assumed. You can write the 2 here like we do, and that won't be wrong. It will be just fine. It's just no worksheet is going to give it to you that way. The STAR test, the end of course exams are not going to give it to you that way. So understand that if you have a root with a 2, that's the same thing as here, as a square root. All right. Let's go down and look at problem number 1. So let's rewrite each expression into the radical form and then simplify it if possible. 36 to the 1/2. So which one of these numbers, the 1 or the 2, will go right here in this tiny corner of the radical? The 1 or the 2? Yeah, the 2, because it is in the denominator, and here's the 1. And we just said this is what kind of root? A square root. Hey, what's the square root of 36? You know this. Yeah, it's 6. You know square root of 36. We didn't have to do a factor tree or anything. Let's go look at number 2 right beside it. So I know that my base is a 4. So what's going to go here as part of the root? The 5 or the 2? The 2. Good, because it is the denominator. The 5 goes inside. So here you get to make a choice. Do you want to take the square root of 4 first? Because that's pretty friendly, you know how to do that. And then go find the 5th power of that? Or do you want to do 4 to the 5th power and make it huge and then go find the square root of that? If you can, I suggest you make things smaller first, although it's not required, it's not law. But I think that would just make things a little bit more user-friendly. These mean the exact same thing. I just put the 5 outside instead of inside. But they do, they really do mean the exact same thing. So what is the square root of 4? Do you remember? It's your favorite. 2. So this is now 2 to the 5th power. And you've got a great brain and a calculator, so if you can do it in your head, great. But if not, remember in your calculator we can practice using your caret. And what does this equal? 32. Good. All right, I want you to pause the video and do number 3 and number 4. Come ask me if you need some help. All right, next example problem. Here we're going to go backwards. They've given us the radical version, and we need to rewrite it into exponential form. Let's go backwards. And again, if we can simplify it, they would like us to do that. Truthfully, you could simplify it before you even put it in exponential form, and that might be easier. Might be. So, let's see. We have 4/3 of this quantity. What did I say? It's being human again today, isn't it? Just human. I have 4 in the radical. That's my denominator. I have 3 that's still a full-size exponent. It is my numerator. So we're going to distribute this 3/4, it's 3/4, onto both parts in the parentheses. Let's go find out how the 16 to the 3/4 turned into 8. Because I think the x to the 3/4, I think you've got that. But how the 16 turned into an 8, I want to look at that with you. So 16. I need 4 of the same number. Smallest thing for 16 is a 2. 8 comes from 2 and 4. 4 comes from 2 and 2. And this root says that I need 4 of the same thing in order to create a bundle. Well, I do, I have them. I'm not looking at the composites. I'm looking purely at the primes. So there they are. So I've got this representative to the 3rd power. So 2 to the 3rd power, 2 cubed, 2 times 2 times 2. Oh, that makes 8. And that is where this 8 came from. Yeah, it's a little bit of doing. Go slow. Write out your steps. Let's try number 5 together. Let's see what we can do. Number 5. We're discussing the cube root of 8 squared. Does 8 have a cube root? I think it does. 2 and 4 and 2 and 2. So I'm not looking at the composite of 8 or 4. I need 3 of the same number to make a bundle. I've got it. So this is now a representative of my bundle squared. This little 2 went right there. So what is 2 squared? 4. Yay for friendly numbers. The end. Let's look at number 6 right beside it. Oh, by the way, this was my exponential form that they asked for. We got it for them. That's what they needed. Okay. So again, we are requested to get the exponential form with a cube root, having started with an 8, but this time we also have an x. So we already know the factor tree of the 8 with the 2's. So I have a representative of that bundle with a 2. Now, do I have another exponent to work with? No, not for the 2. But what about the x? Did I have 3 x's to mess with? No. So this x has to go into an exponential form. What exponent is right here when nothing is showing? That's right, it's a 1. So this becomes x to the, there's a fraction. The root value goes in the denominator. The exponent here, the numerator. And that is your final answer. How you doing? It takes some practice, but you're going to be okay. I want you to tackle number 7 and number 8. If you need some help, come and talk to me. Pause the video. All right, in our next example, we're going to talk about a simplified expression where we have exponents that are fractions. We're going to use various rules that we've already learned: product rule, power to a power rule, quotient rule. We're going to combine by way of those 3 and then shift into the radical form, or possibly the exponential form, just depending on what they want us to do. All right, so this right here, we're going to start with the product rule. So with the product rule, we add our 2 exponents together. And with that, 1/4 plus 1/4, you can either work in your head or you can use your calculator to help you. You get 1/2. So let's now write this into the radical form. So I have a root. There's my base. Remember, your denominator is here in the corner of the radical, and my numerator is their full size. So I put the parts where they go. Just like we said at the beginning, put the parts where they go. But we remember square roots, we just don't write that. It's just understood. It's assumed that that is what is there if nothing is showing. Okay? Let's try number 9 together. So I have the same base multiplying together. What do we do with the exponents? Add them. A to the 2/3 plus 1/4. You can use your calculator to help you if you don't remember or want to take the time to get a common denominator. So this ends up being a to the 11/12. Did you get that in your calculator? If you did, great job. Now let's write this in radical form. Here's my radical. Here is my base A. Which number goes right here in the corner? The 11 or the 12? Good job, it's the 12. And the 11 goes right inside. You're starting to get the hang of this. Nice job. Done. That wasn't bad. Let's go check out number 11. Okay, what are we going to combine? I have a 5. And then I'm going to combine my x's with their exponents. 1/5 plus 2. Use your calculator to help you with those exponents. Get 5x, and the x has an exponent of 11/5. Great. How do we write this? The 5 does not have an exponent. It stays out in front of the radical. X has the exponent. It goes in the radical. The 5 is the denominator, so it's here high and tight in the corner. The 11, full size inside. Good job. Okay, you do number 10 and number 12, and then we'll finish this up. Come and ask me if you need help.